Every 10 seconds, a developer is lost to the Rust programming language. You too could save them from this misery and painful experience. Only kidding, that got your attention, didn't you? I'm Mark Steele, this is Technically Minded, and I should start this video by saying I am some random person on the internet, on YouTube, as you're watching this video right now. You probably shouldn't take advice from me, but I do have a bit of experience with programming and whatnot, and I'll be quite frank, the correct thing you should be doing is pick the right tool for the job. But if you've been around the programming world recently, you will have heard about the Rust programming language. Who hasn't? It's been going round and round, and the people you speak to that use it seem to love it. Everyone outside it's going, oh, that's a bit interesting, or oh, that seems a bit complicated, and giving up fairly quickly, because the learning curve is more like a learning cliff, is the way I've heard some people put it. And from what I've seen, that's probably quite accurate. The usual things you hear about Rust and why you want to be doing it is get rid of the garbage collector. You can only write code that can actually run. You know, you're not going to get, especially from a systems programming language, you're not going to run into fun things you do with C, where you go to run it and then you get a seg fault. Apparently with Rust, if it compiles, it should run and everything should be good. You're not going to get bug-free. Anyone that claims bug-free is talking out their backside, but that's one of the things you sometimes hear as well. The reality is you get some nice benefits without having to have a garbage collector there as well. And I hate to break it here, but 99% of us that are writing code that is used out there in the world today, or leading teams that are writing code that's out there in the world today, don't need to worry about the garbage collector. In fact, in my entire career, I've heard only once where the garbage collector has been a problem, and that was solved by changing one of the parameters on the garbage collector. Memory management is one of those things that's sort of solved. In fact, it is, we can treat it as solved for 99% of us. For those of us that are just writing the programs that aren't going to be used by millions and billions of people, memory management's a solved issue. We don't need to be worrying about it down at the lower level. It's a bit different if you're writing something for embedded. I totally get that. Embedded, fine, there's low resources. You need to be as clever as you can with memory management. And there are people who, maybe even you, dear viewer, that are building things that are going to be massively code-scale or whatever. I mean, every single byte that you can get back is very important and will help with performance. I understand there are going to be those edge cases out there, and there are going to be scenarios where that is the right thing. But for the 99% of us that are writing crudware, no, it's not such a big deal. I also hear that Rust, if you talk to people that are very excited about it, it's highly performant. And I have seen some evidence of that directly. I work with a team that use Rust, not for the vast majority of what we do, but for chunks of what we're delivering. And when you've seen things delivered, it does run very fast. It runs very efficiently. But let's be real, the vast majority of the applications you and I are writing are going to be waiting on I/O for the vast majority of the time. They're not sitting there burning CPU cycles over and over. It's very rare that we'll be running into highly CPU-intensive applications. It does happen. If you're trying to process video or you're calculating large-scale numerical processes and things like that, there are scenarios where you will be CPU-bound. But you'll probably find that for the vast majority of us, even if you do have those applications, they tend to be quite time-constrained. They're not running against the CPU the whole time. You're still doing a lot of idling. If that's not the case, and actually you are writing applications that are CPU intensive all the time and need to get every single cycle back that you can, yes, go for a lower level language, write that high performance code, go for it. But for the vast majority of us, we don't need to be fiddling around, messing around going, well, I need to make sure that the borrow checker does da. I need to make sure this memory is safe. I need to da. You don't need to be worrying about that. You should be worrying about the higher level business abstraction and just trying to solve that problem. Trying to solve the problems that were solved by computer science decades ago again because you think you could do it better, it doesn't seem the right use of resource and time. That's just my interpretation. You might think otherwise. And in fact, if you do think otherwise, I want to see you down in the comments do that. And while we're on the topic of memory management and we're looking at the safety of that, I will give you, Rust is fantastically ahead, and we could even say this like Zig as well. It's fantastically ahead of what we used to do in C with all the malloc and free, and yeah, generally we tended to forget about freeing in certain places. We might reuse memory in the wrong places and we get into undefined behaviors and all that sort of thing. Compared to those fruit guns, Rust is fantastic. For the vast majority of us that are writing web apps that are crudware, we don't need to be worrying about memory management. We just need to be solving the business problem. Request is made, it gets processed, it goes out again. Now, if you've got a team of people who have learned Rust in their own time and it's fantastic technology, absolutely love it, and you can knock it at 100 miles an hour, go for it. And in fact, team skills is one of the big things you should be thinking about when you're deciding what programming language am I going to write something in. Now, if your team isn't skilled up in Rust, that doesn't mean you can't use it. It just means you've got to train people up in it. And it means you're going to have to spend some time, effort, and money. That's a business decision. That's not a technical decision. It has some technical input, whether you choose something like .NET Framework and Java and all the complexity that comes with that, or you want to choose something that's lean and efficient, or even you choose something that is into the functional programming world like Haskell. Yes, they all come with their own range of benefits and they all come with their own range of downsides. You have to make that choice. Do we pick something that actually we know we can get developers in and we know they're already trained up and they'll pick up fairly quickly? Or do we choose something that's a little more esoteric? They'll still get their heads around it. It'll take a little bit longer because we've got to learn it before we can work with it. But once we're up and running, it becomes with benefits X, Y, and Z. So that is the lesson I want you to learn here. Don't take advice from random people on the internet or saying, go pick language X, Y, and Z or framework X, Y, and Z because it is the best thing in the world. You need to step back and go, okay, does it solve my problems? And does it solve in a way that I can actually get there sensibly? And that's what you need to be walking away with. Take that away in your head and don't just listen to people that are going, yes, you must use the Rust programming language. Or maybe like this video title saying you should avoid it at all costs.